All right, Algebra 2, Lesson 3-3, Factoring with Advanced Ninja Star. Today's date is Wednesday, September 30th, and I need to fix the board, I know, 2020. What is our objective? Come on, go.
Factor quadratics when the leading coefficient is not 1.
There it is. And you've seen that before. Yesterday we did one where the leading coefficient is not 1, but it was because there was a greatest common factor. This is one where even after factoring out the greatest common factor, the leading coefficient still is not 1. Okay, so it's the same two steps over and over. What are the two steps when we factor? Jenny? There it is. So factor out the GCF. Do you want to do the second one as well, Jenny, or do you want to give it to someone else? Ninja Star, there it is. And I'm going to go ahead and now make this advanced. But again, if you know what you're doing, if you really, really know what you're doing, and you know that the leading coefficient is 1, then you can use the normal Ninja Star. You don't have to use the advanced Ninja Star. If you don't know if you should use one or the other, use the advanced Ninja Star because it works on everything. Everything with 3 terms, a trinomial that is. Eventually we'll do 4 terms. All right, so again, distributing versus factoring. Let's go ahead and multiply this out. So if I have my general rectangle, I'll do a line and then a line. I'm going to put the 2x plus 3 on the top. I could have put it on the left. I just randomly decided that. 3x minus 5, I'll put that on the left. All right, rapid fire. Multiply to get to the cells. 3x times 2x. Charles? 3 times 3x. Andres?
9x.
Negative 5 times 2x. Jenny? Negative 10. X, there it is. Perfect. And 3 times negative 5. Josie? Negative 15. And then we add these all together. Notice that the like terms are on this diagonal. I have a negative 10x and 9x. Who can add these together for me and combine like terms? Jose?
Negative x.
Oh yeah, so negative x for that middle term, I agree.
6x.
There it is, and then we box it. Perfect. So that's going forwards, and we've seen this problem before. Now we are going backwards. So when do we use advanced Ninja Star? Just in general when we have a second degree trinomial. That's the only condition that you need. Again, second degree, I mean, we talked about this yesterday. I'll just re-annotate them the same way. Second degree means what? Review. Regurgitate from yesterday. Charles?
The highest exponent is 2.
Highest exponent is 2. Perfect. And I'll put in notes for the variable. Variable. I don't want people getting confused, and I can give you guys a question that looks like 3 cubed x squared plus 5x. Yes, the highest power is 3, but it's referring to the 3, the constant term, and not the variable term. This is still a second degree binomial because the highest degree of the variable is 2. All right. So, and then trinomial again. What is a trinomial? Another quiet raised hand. Wyatt?
That means that there are 3 terms.
3 terms. All right. So less conditions on this one, which means it is applicable to more types of problems. And notice that the Ninja Star has these 2 little, I don't know, helpers on it. Maybe they're like, I don't know, what would the analogy be? If this is a Ninja Star, are they like needles that come out of the Ninja Star as you throw it? What do we want to call these things? Yeah, okay. It's a needle Ninja Star. It has needles on either side. These are going to turn into your fractions after you reduce your fractions. Yeah, so again, it's going to be the same procedure if we read down here. It's a little bit different. We used to only put C on top. Now we're putting A times C on top. So we'll go ahead and write up here, A times C. A times C. B goes on the bottom, so I can write that down here. B is on the bottom. Again, I'm asking what 2 numbers multiply to the top and what 2 numbers add to the bottom. And I skipped a step 4. I should go back to step 3. Sorry about that. And the top left and the top right, we need to put, and this is kind of the trickiest part, so let's pay attention. It's going to be the AX term on top. What do I mean by that? The A, obviously, is the leading coefficient. That's the A. But notice I didn't put AX squared. This just said AX. What I'm really doing is I'm taking the leading coefficient A, and I'm taking the middle variable with its degree. If this was an x to the power 4, I would have put x to the power 4 here. I grab the middle variable with its degree, combine that with the leading coefficient, those two numbers go here and here. And you might be saying, well, isn't that always going to be an x? For now, yes, but not for this entire unit. Eventually, I'm going to be giving you harder and harder questions where it's going to be ax to the power of 8 plus bx to the power of 4. Always do to the power of 4. Whatever this middle x or whatever this middle variable to the power is, just copy down that middle variable. I'll talk about that more once we get there, but now you've seen a preview. So in our notes, I would say ax goes here, ax goes here, and then we actually solve the problem. So I'll follow the two numbers, so I'll call this number 1, number 2, and then I need to reduce these fractions. And there's not a really good way of doing that because I don't have an actual example in front of me. But say, I'll just make one up. If this was like 9x over 3, you would reduce this to 3x over 1. Just treat this as a fraction. Treat this as a fraction. Once you reduce it, write it on the needles over here on the left and the right. Reduce the fractions. And then once you have the fractions reduced, again, it's going to be something along the line of ax plus number, we'll call it the first number, and then ax plus the second number. And this might be a little bit confusing notation, but I think an example will help us quite a bit. So maybe I'll say over here, can I write sideways on my tablet? Ooh, what if I just turn my tablet sideways? Ooh, that's going to be really trippy. How do I go this way? There you go. Let me try. Whoa, I cannot. Okay, I tried. You need to reduce that fraction. Maybe I can just do diagonal this way. You need to reduce that fraction. Let's see an actual example. I have this trinomial. All right, first step is always to do what? Go back to the very top. First step is to, Jade? GCF, cool, there it is. GCF of 2x squared, 3x, and negative 35 is what? Find the greatest common factor. 1 hand, 2 hands, 3 hands. Charles, go. 1. Which means that we can't really factor anything out. So we're done with step 1. We've checked it. You always check to see if there's a greatest common factor. In this case, you don't really need to do anything. So then we move on to advanced ninja star. Let me set it up for you guys. There's my ninja star. I make it an advanced ninja star, and I go ahead and write out the needles or the reduced fractions on either side. All right, I don't know how to fill this in. Oh, I do, but you guys help me. Pretend that I don't know. We'll do one number at a time. Wyatt, you go first.
So on the very top one, you're going to want to multiply a times c, which is going to be 2 times negative 35, which is going to be negative 70.
Thank you. And I'll give it to another person after that. Charles, next number.
3 should be on the bottom.
Perfect. Next number. We'll still have to fill in the top left and top right. What numbers go there and there? Gunnar.
2x squared. Oh, negative 35.
Like that? Not quite. Fernando?
Positive 10 times negative 3. No, negative 7.
Where's negative 7 coming from?
Or, actually, never mind.
Okay. You calling someone, Fernando?
White.
So on the top right and left, you're going to want to just put the term 2x without the square.
All right, this is correct, but explain why. Well, where did the 2 come from? Why? Where did the 2 come from?
The front.
What is that front called? You remember the term that we call it? Just with an L? No? Does anyone else remember why you can call someone?
The leading coefficient.
There it is, yeah. So we put the leading coefficient, that's a 2. And then someone else. Where does x come from? Charles?
Middle variable.
Yeah, middle variable. We just copy this down. If this was an x squared, I would have put the x squared down here. Since it's only an x, I'm just writing the x. All right, perfect. So that's our advanced Ninja Star setup. But now I'm asking the exact same question. What 2 numbers multiply to negative 70? 1 and 70. That's one of them, right? 2 and 35. Now check that both those numbers also add up to 3. And I guess I should have had one of those negative, right? Negative 1 and positive 70. But those don't add up to 3. Find 2 factors of negative 70. 1 times 1 is negative 70. That also add to 3. Raise your hand once you've got it. I have 5 people that got it so far. 6. And I think this is the most important part of the lesson, in my opinion, so that's why I'm going to give more time allocated right here. Go through the factors of 70. 1 and 70 didn't work. 2 and 35. No way to get to 3. 5 and 14. Closer, not quite. Keep going, keep going. Fernando.
Positive 10, negative 7.
Positive 10, negative 7 does indeed work. Check it. 10 times negative 7 does get to negative 70. Add them together now. 10 minus 7 is 3. All right, we're not done. Now we need to reduce these fractions. I have the fraction 2x over 10. I divide by the greatest common factor, and this reduces to what? Oh, let me check for again. And I forgot to uncheck this one. Ooh, I'm so bad. Go for Gunnar. Jenny, go. Yes, 1 over 5. And we have to be careful too, since we had an x, we're going to copy down the x as well. Great. And typically, when we say 1x, we really just mean x. So let me go ahead and just call this x. That always happens. I don't know what's wrong with that program. Okay, so x over 5. What about the right fraction? 2x over negative 7. How do I reduce that one? Andres?
Wouldn't it just be 2x?
Yeah, can't do anything. 2x over negative 7 stays the same. These 2 fractions, you need to write them in the correct form. We're finally on step number 6 now. So we just reduced the fractions, step 5, and now I write in the correct form. Who can help me do that? Charles.
Would it be x plus x over 5?
Oh, just x plus 5, so whatever that bottom is.
Okay. X plus 5, and then x minus 7.
Really close.
So x minus 7?
There it is.
Okay, so the numerator is before.
There it is, yeah. That was your first example. This is the time that you really want to ask questions because you're about to go off into the mathematical wilderness on your own. I might help you with the next one. We'll see. All right. I'll leave these steps up here. I can't really do that, can I? Try this one on your own. Have some scratch paper. If you need some scratch paper, ooh, I'm out of blank paper, aren't I? Yep, I'm out of blank paper. There's random other scratch paper that you can grab up here if you need to. Try example 2, then example 3, and that's it. We just got 2 more examples to go. The first step in example 2 is to factor out the greatest common factor. What is the greatest common factor? Jade? 2. You are correct. So when you factor out the 2, you're left with negative 6x squared minus 7x plus 6, which isn't going to work. And I realize I need to change these notes a little bit.
Wait, it wouldn't be plus 6 though, right?
Oh yeah, sorry. Teacher error, nice. Plus 3. Good job, log it.
We don't have our log. We don't have our.
Oh, dang it. Okay, let me go hand those out in a sec. I really need to change these notes to say second degree trinomial with positive, I can't spell, positive leading coefficient. So you need to make it a positive. So if I come back down here, right now I have a leading coefficient that is negative. How would I make that a positive? Just by factoring. Fernando?
Factor out the negative.
Okay, what would that look like then?
-2 and then 6x to the second plus 7x plus 3.
Ooh,
Oh, minus
there it is, yeah. And now I can use Advanced Ninja Star on this inside. And again, just keep copying down that -2, keep copying it down, and then you're done. All right, help me set up the Ninja Star. Those of you that are working on Khan Academy, you can ignore me if you want, or you can help me. It is your choice. There's my Advanced Ninja Star with the needles coming off to either side. Andres, set it up, please, entire thing.
Okay, so for the top it's going to be -18. For the bottom 7. And then on those top left and right, they're going to be 6x and 6x.
Perfect.
And then on the bottom,
Oh, yeah, go ahead for it.
oh, you want me to give this someone else?
You can go for it.
So it's going to be -2 and then 9.
-2 and 9. And that solves our Advanced Ninja Star. Perfect. I'll let someone else reduce it. Yep, -2 times 9 is -18. -2 plus 9 is 7. Can someone reduce and write our final answer? Jade.
On the left you have 3x over -1. On the right you have 6x over 9. And 6x over 9.
Yeah, that can be reduced though, right?
2x over 3.
There it is. 2x over 3, which means our final answer is
-2 times 3x minus 1 times 6x. 2x plus 3.
there it is, and we box it.
So, yeah.
One of the quickest ways that you can tell if you've reduced your fractions correctly is this. Does the first term as the leading coefficient of your binomial for each of these, 3 and 2, do those both multiply to the original 6? The answer is yes, you've reduced correctly. If you had 3 and 6, that would have multiplied to 18, which doesn't get you back to 6. Check your first terms to see if they multiply to 6x squared. All right, let's do example 3. I know there's only a handful of you that have done this one so far, but I do want to get you guys some time to do some homework. First step, go. Who's got it? Jose. Perfect. Do you know what the GCF is? 3. All right. When I factor out 3, I'm left with? Perfect. All right. Now we're going to set up the Advanced Ninja Star. Who can help me do that? Have the needles on each side. Chunk, chunk. What goes where? Uh-oh. All the people are on Khan Academy. Andres.
Okay, so for the top it's -48.
There it is.
And then for the bottom it's going to be 13. And then that is going to be 12x. And same on the other side.
Perfect. All right, Andres has set up our Ninja Star, our Advanced Ninja Star. And now the question becomes, what times what is -48 that also adds to 13? And that is kind of a tricky problem. And I'll give you guys this basically giveaway hint with my spotlight search. Did you know that 16 times 3 happens to be 48? So what's the answer for completing our Ninja Star then? I'm going to give this one a set from Andres. I want to at least go alternating, not calling the same person over and over again. Sorry, Andres. What goes on the bottom of this Ninja Star? I'm basically giving you the answer right here, if you just want to read it off. Yeah, Gunnar? Really close. I'll write it down. 16 and 3. How does that add up to 13, though, and get to a negative 48? -3. There it is. All right, so Gunnar's filled in our Advanced Ninja Star. Now I just need to reduce each of these fractions. Sorry, Gunnar, I have to at least alternate. How do I reduce 12x over 16? How do I reduce 12x over negative 3? Wyatt.
So for 12x over 16, you're going to want to find the greatest common factor. So out of those two, I think that's going to be 4, so on the top. So it's going to be 3x on top, and on the bottom it's going to be 4. And on the other side, the greatest common factor, I'm just going to use 3. You could also use negative 3 though, but 3 can go into 12x 4 times, so it'd be 4x on top and negative 1 on the bottom.
There it is. Thank you. And Wyatt says something interesting that I don't know if it's true or not. So yes, you could factor out by negative 3, and that would give you a negative 4x and a positive 1. The problem with having negative 4x is negative 4x times a positive 3x doesn't get back to a positive 12x squared. So they have to both be positive. So the general rule of thumb here is if the denominator is positive, leave it positive. If the denominator is negative, it should also be negative when you reduce it. All right, and who can write our final answer? And then we'll be done with the notes. Andres, go.
So it's going to be 3 parentheses, 4x minus 1, and then 3x plus 4.
And then we box it. I'm glad that you remembered that 3 out front as well. That's a very common mistake to forget him or her. All right, and that concludes the notes.